everyone, and welcome to Chem Talk, where today we'll be discussing chemical equilibrium and its applications to chemistry. So, let's talk about it. In general, equilibrium is defined as balance, and like many things in life, chemical reactions also need balance, specifically in reversible reactions. A reversible reaction is where reactants can form products and products can change back into reactants. And this is important because chemical equilibrium is achieved when the forward and reverse rate of a reversible reaction are equal and have reached a balance. So let's take a look at this model to better understand equilibrium. In this reaction, the hearts represent reactants and the circles represent products. So we start with only reactants, and as the reaction progresses, we have less reactants and more products. Now if you notice, there are 3 hearts and 4 circles 20, 30, and 40 seconds into the reaction. This means that equilibrium was reached 20 seconds into the reaction, because the forward and reverse reactions had to have been going at the same rate in order for the concentrations of the reactants and products to become consistent for the rest of the reaction. There are a few more things that are important to note about equilibrium reactions. A reversible reaction doesn't end when equilibrium is reached. It continues possibly for forever. But we can't notice any change because this balance has already been achieved. In addition, a reaction will adapt to regain equilibrium if it's somehow disturbed. In a reaction, if it undergoes a change in pressure, concentration, or temperature, the reaction will shift to the forward or reverse reaction in order to regain equilibrium. Check out our video on the Chatelier's principle to learn about this in more detail. Now, it's time for you to test your own understanding of chemical equilibrium. So pause the video and answer the following questions by yourself. So this question asks us to draw a graph to represent the Haber-Bosch process, which is how we make ammonia. So let's draw the reactants first, the nitrogen and hydrogen. Both start at high concentrations in order for them to react. As time goes on, their concentrations decrease because more reactants are being turned into products. And because this is a reversible reaction, equilibrium must be reached, so the reactants eventually flatline because no changes in concentration are occurring anymore. For the ammonia, our product, we start at a concentration of 0 because the reactants haven't reacted yet. As time goes on, more ammonia is being produced, so the concentration increases. And the line flatlines at the same time as the other 2 lines because equilibrium between reactants and products are reached at the same time. This next problem asks us to identify when equilibrium was reached in the reaction represented by the model. So if you notice, from 30 seconds onward, we are only left with products in this reaction. Well, equilibrium only occurs in reversible reactions, and products and reactants have to be left over in reversible reactions. So this is actually a trick question. Equilibrium wasn't reached in this reaction since it's irreversible. Now, let's discuss how chemical equilibrium applies to our lives. In our bodies, hemoglobin and oxygen react to form oxyhemoglobin. When equilibrium is reached in this reaction, enough oxygen is transported to our cells, allowing for us to stay healthy. However, when we are at higher altitudes, the air pressure is lower, causing the equilibrium to be disturbed. This is how altitude sickness occurs. Now, before you go, let's recap what we covered today. Chemical equilibrium is when the forward and reverse rate of a reaction are equal. We can see this when the concentrations of reactants and products become consistent at a point in the reaction. These reactions never end, but equilibrium may be disturbed by changes in temperature, pressure, or concentration. And equilibrium reactions are present in even our bodies, such as the reaction between Hb and oxygen, and this keeps us healthy. So that's all for today's video. Thank you so much for watching, and please visit us at www.chemistrytalk.org to access more amazing chemistry lessons. Bye!